It was 1994. It was dark, so no one saw two silhouettes opening the emergency exits of a glass dome complex in Arizona known as Biosphere 2. They were determined to free 7 people locked inside for a month, risking their lives in the name of science. The mission was accomplished, but they got hit with trespassing and vandalism charges. The vandals were Abigail Ayling and Mark Van Thillo. They were among the first 8 poor devils who lived in that place as guinea pigs, and they didn't want anyone else to go through the same horrors they had experienced. $150 million were spent to see if humans could create suitable living conditions on other planets, like Mars. To do this, scientists built a mini-world with over 3,000 species of plants and animals. Biosphere 2 was a sealed-off 3-acre habitat, complete with its own mini rainforest, a private beach with a coral reef, a grassland savanna, a marsh, and even a desert. Between 1991 and 1993, nothing could enter or exit that place. The group of 8 people locked inside called themselves Biospherians, rocking matching Star Trek-like jumpsuits, growing their own food, and breathing their own air. They began with high hopes and a 5-star hotel-style breakfast, but things took a darker turn over the months. The whole team was starving and turning orange. In Biosphere 1, which is the real Earth, you can order a pizza in 2 minutes. But inside Biosphere 2, it took them an endless 4 months to whip up a margarita-style pie. They had to harvest wheat for the dough and milk goats for the cheese. The goal was to be completely self-sufficient, and they became part of an atmosphere, quite literally. When they breathed out, their CO2 fed the sweet potatoes they were growing. And those sweet potatoes became part of them since they were essentially eating the same carbons over and over again. They had so many sweet potato feasts that their skin actually turned orange from all the excess beta-carotene. What seemed like a funny situation at the time highlighted a big issue. The crop yields in Biosphere 2 were a total disappointment, and the crew was starving. They were going crazy from hunger, and moments of sudden anger led to doing regrettable things, like stealing bananas from the basement storeroom. At some point, the freezer had to be locked. Over the first 6 months, each of them lost between 18 and 58 pounds of weight. Every day, someone took charge of weighing out fresh food for the cook, logging the information about nutrients into the computer to make sure the crew hit their recommended calorie, protein, and fat goals. Initially, meals were served buffet-style, but as the crew got hungrier, the cooks started to meticulously divide their food into equal portions. Their diet, mostly sweet potatoes, carrots, fruits, and occasional meat on Sundays, were supposed to keep them going during those exhausting 80-hour work weeks of heavy physical labor. Biospherians were leaving every meal still hungry, and they had recurring dreams of McDonald's hamburgers, sushi, Snickers bars, and cheesecake. The air was running out. The entire place was completely sealed, with steel and glass at the top and a solid steel floor underneath. Managers made sure to check everything coming in to avoid synthetic materials emitting harmful gases. Living areas were furnished with wood and wool, and they couldn't use chemical deodorants or blow out birthday candles. Biospherians were counting on the food they grew and their many rainforests to produce enough oxygen for them to survive. However, they were losing oxygen very fast, drowning in their own carbon dioxide emissions, and worst of all, they had no idea why. With another 9 months of the experiment to go, oxygen levels had dropped from 21% to around 15%, which feels like living at the top of Mount Fuji. They felt awful, basically dragging themselves around the biosphere. They couldn't even finish a sentence without stopping to catch a breath. Then sleep apnea kicked in, with some of them waking up gasping for air. To bring down the carbon levels inside Biosphere 2, they tried some desperate moves, like growing plants like crazy, cutting back on watering the soil as much as possible, and even giving up on tilling. Nothing worked. So everyone decided they had hit a dangerously low point and asked for help. Refrigerated trucks showed up to pump more pure oxygen into Biosphere 2. As soon as the gas started flowing in, they burst out laughing and began running around. The ecosystem was a total mess. Hummingbirds and honeybees vanished after a couple of months, so plants weren't getting pollinated anymore. Worms and broad mites attacked crops, and cockroaches just took over. 4 species of cockroaches were brought inside to recycle organic matter, but the regular household cockroach was the ultimate survivor. They somehow sneaked in and multiplied, becoming a serious threat to crops. At night, the kitchen got flooded with cockroaches as soon as the lights went out. To combat the infestation, the group greased coffee mugs with lubricant and put pieces of papaya inside as bait. Roaches would climb inside, but they couldn't scale the slippery sides to escape. Being hungry, lacking oxygen, dealing with bug infestations, that's enough to make anyone go nuts. Heated arguments led to cups being thrown and people being spat at. Eventually, the whole group just split into 2. They stopped talking and could walk right past one another in the hallways without even making eye contact. Half of them wanted more food and oxygen to continue the research with some dignity, while the other half believed in survival without external help, no matter the costs. The truth is, the sealed chamber had been breached long before that. Just 2 weeks after they got inside, a biospherian named Jane Pointer cut off the tip of her finger in a cooking accident while making rice. The mission's doctor tried sewing the tip back on, but it didn't work, and her finger turned black within days. She went to a hospital outside for surgery, and a couple hours later, she sneaked back inside, carrying a duffel bag filled with supplies like computer parts and color film. Reporters would only learn of that sneaky delivery months later, and because of that, many people have questioned the credibility of the entire experiment. Media treated the experiment like a reality show, branding it as trendy ecological entertainment. Headline news around the world made it sound as if they were on the brink of losing their lives, to the point where families were concerned, calling the biospherians to check if they were really okay. The group felt like they were in a human zoo, with tourists coming from far away to peer into the glass cage. In the first 6 months alone, more than 150,000 people visited the place. Biosphere 2 ended up becoming a pop culture punchline, inspiring a comedy movie called Biodome and decades of funny sketches. You might be wondering why none of them quit the experiment and walked out the front door. Well, none of the environmentalists wanted to be the first to admit it was too much to handle. Plus, they were all still hopeful they could somehow crack the puzzle of building Earth number 2. By the end, they had managed to find 7 tons of missing oxygen. It had been absorbed by the concrete. Even though being breathless all the time might seem like the biggest challenge they face, the biospherians said that learning how to deal with people in a closed environment was even harder. It looks like the experiment was a huge failure, but the group did learn a lot of valuable lessons. They proved that a sealed ecosystem could work for years. They contributed to studies on reef restoration, and their farms showed that high productivity and full nutrient recycling could be achieved without toxic chemicals. In case you wonder, this wasn't the end of the glass complex. The second mission inside Biosphere 2 took place in March 1994. Now, you can go back to the beginning of the video to understand how that worked out. So, imagine that ChatGPT will start perceiving itself as a person and will feel emotions in a few years. Many people are afraid that it will want to take over the planet. However, this fact won't be as important as the question people will start asking themselves at that moment. If humanity has created a machine with self-awareness, then could it be that humanity was also created artificially? Now, artificial intelligence lives on the internet, computers, and in digital reality. But what if we also live inside a huge, powerful computer? What if our universe is just a simulation? The most extraordinary thing is that some facts seem to point to this. There's a whole science in the world that studies this theory. It's called information physics, and it assumes that time, space, and matter are not fundamental natural phenomena, but bits of information. This information forms a picture that creates the laws of physics for us. For example, we feel cold and warm not because atoms get cold or warm, but because their movement accelerates or slows down. The speed of particles can be like bits of information. Billions of them could form the picture of reality. Once, philosopher Nick Bostrom said that an advanced civilization could create such complex technologies that simulations of these technologies would be indistinguishable from our reality. And Elon Musk said in 2016 that we were most likely in a simulation. Wow. The laws of physics resemble a giant code that programmers write when creating apps or games. For many of us, all these complex trigonometric equations and formulas of the laws of physics are too complicated. Tell me about it. But scientists who understand this issue see that the principal workings of these laws are beautiful, and this may suggest that someone deliberately created this beauty. Virtual worlds, apps, or games are based on information processing. If you delve into this information, you'll see that it consists of bits and pixels. Any picture on your phone screen is pixels, and any file transfer process is based on bits. They add up to bytes, kilobytes, megabytes, and so on until a bigger picture is formed. And if our life is a simulation, it must also consist of bits. In our case, pixels and bits are atoms and other particles that make up our universe. There are processes inside your computer and phone with maximum speed limits and computing power. If you start exceeding it, then your device will start working more slowly. So, in our reality, there is also a maximum speed limit. This is the speed of light. When an object starts moving almost as fast as the speed of light, time slows down for that object too. Also, time flows more slowly near a black hole. This object, with an unimaginable gravitational mass, can be something heavy that overloads the processor's computing power. There's also such a thing as quantum entanglement, in which two particles can be connected even though they're far away from each other. Electrons travel around an atom. They are connected, and if the property of one changes, the second one will react. And even if you place these electrons on different sides of a galaxy, they will retain this connection. How is this possible? Scientists don't know. A double-slit experiment is one of the most famous experiments that hint that our world is a simulation. The existence of this experiment can be reduced to a simple thesis that the world exists only when we look at it or interact with it through touch, hearing, and other senses. So imagine that you've launched a new game on an old computer. Sometimes the game map freezes. In the game, you turn to the left and see how the mountains and the roads are getting loaded. Then you turn to the other side and the same thing is happening there. In other words, the world in the game only loads when you look at it through the eyes of your character. This is necessary to facilitate the work of the processor. It's much more efficient to get a piece of information about the world when you look at it than to keep the whole world running simultaneously. Remember this. And now let's move on to the experiment. So, you have a device that fires small balls of light, photons. You release photons from the device and they crash into a blackboard, leaving white traces on the black surface. Now, put a wide plate with a little vertical slit on it between the device and the blackboard and fire photons again. The balls start crashing into the plate, but some of them fly through the thin gap. They smash into the blackboard and leave a vertical white mark on it. Everything looks quite logical, but now cut another slit with the same length and thickness in the plate. You release photons toward the plate. Some of them fly through the two slits. What do you think the trace on the board should look like? Two white vertical stripes, right? Well, take a look at the board. It's covered with many vertical lines. When photons pass through the plate, they acquire the properties of a wave and crash into the board, leaving a strange trail as if they've passed not through 2, but through 10 slits. So, at what point do they change their trajectory? Let's take a look. So, you stand between the board and the plate to see how particles turn into a wave. The device releases photons. They are passing through the two slits. Nothing unusual. There are two vertical traces on the board and no waves. You close your eyes and release photons again. This time, they behave chaotically and leave many lines on the board. That is, their behavior changes depending on the observer. When you look at them, they behave logically. But when you don't look, the laws of physics seem to stop working. Does it remind you of anything? It's like you're playing a game and looking at the world around you, which is loading. But if you don't look, the world stops working. Scientists still don't have a clear explanation of why particles behave differently when there's no observer. Hey, maybe they're shy. And this is not the only mystery. In the world of quantum physics, many laws of nature don't work. This is a science that gets more questions than answers every year. If we imagine our universe as a large hologram, then quantum physics would be its program code. What if people someday understand this code and learn to change it? This would allow us to transform space, time, and matter. The whole reality could be rewritten. Does the code say that material objects can exceed the speed of light? We would rewrite it and make the speed limit 100 times higher. Does 1 hour last 60 minutes? What if you change one line of code and make 1 second as long as 1 year? A few software changes in the laws of physics would make it possible to turn snow into gold and the ocean into powdered sugar. The whole universe would turn into a vast playground. It seems cool at first glance, but people would probably lose control soon. The universe would be in chaos, and the beauty of our world is in the order that exists here. Now let's go back to artificial intelligence. Suppose its power reaches the level of the human brain, and it will become aware of itself. In that case, it won't come as a shock to it because it will most likely know the history of its appearance and stages. But how will we react if people discover they are a computer program? A computer program is too simple a word. A human is a complex, intelligent, multifunctional organism that experiences emotions, contemplates beauty, has abstract thinking, and much more. The term creation is more appropriate here. It won't matter if we were created artificially because our creation will still be beautiful and complex. Besides, remember that good video games or apps can be made only if developers love their creations. Now, I don't know about you, except you're a nice person, but if I had the opportunity to bring something from science fiction to life, this would definitely be a teleportation machine. I'm so tired of traffic and spending hours traveling abroad, and the idea of getting teleported to any part of the planet within seconds sounds way too appealing. So yeah, obvious choice. Let's imagine we already live in that world from science fiction, and the teleportation machine exists. If you want a fancy scientific name for what we're doing now, it's called the thought experiment. Thought experiments are common practices in philosophy, and they explore creative and unlikely scenarios. The point is not to figure out the truth about these scenarios, but to explore what we believe about them. We're going to have our own thought experiment and imagine a world where teleportation is something regular. What happens then? And what are the possibilities of that world? Let's take a stroll around London, the capital of the UK. Yes, it's still the capital of the UK, even in this reality. See that red telephone booth? Let's walk in. No, I don't want you to call your grandma and ask her about her week, even though you probably should do it later. In this world, the telephone booth is a teleportation machine. Because, really, who needs them to make calls anymore? They're utilized for something more useful these days. So now, all you need to do is choose your destination. Use the numbers to type in the zip code of where you want to go. Now, on the screen, you see some options. Those are the exact coordinates of the teleports in your destination area. Of course, you just can't teleport yourself to any random place. This is not safe, because you can bump into someone who's already there. So there are special locations. Where do you want to go? New York? Okay, type in 10020. Now, you need to pick a location. Let it be this place. It used to be a newspaper kiosk. Yes, those were utilized too, because no one reads newspapers anymore. Let's say you're Alex. Can I call you Alex? Well, I will. So, Alex, you confirm your choice and press that button. Suddenly, you feel a breeze, and then you feel that you're dissolving into tiny pieces. Don't worry, it's normal. You're getting scanned, and your body, your consciousness, your feelings and emotions, your experiences, your skills, all of you just turn into atoms. It doesn't hurt. Then, a sudden rush, just half a second like during free fall, and then that breeze again. You can feel that you're getting your pieces back. At first, you can barely feel your body, but just a second later, you start feeling your arms, your legs, your heartbeat, your whole body. You're whole again. You're you. But are you really you, Alex? Are you sure about that? Are you sure that every single piece of you has been delivered to your destination? Are you sure that your consciousness has traveled safely along with your body? Are you sure that this really is the original you, Alex, and not just some perfect replica? Imagine there was a crazy scientist who created your duplicate. Would that duplicate be you? No, of course not. But if you ask your duplicate that question, they would definitely say that they are you. Then why are you, Alex, so sure that the you standing here in the middle of Manhattan is the original you, and not that duplicate who is so sure that they are you? Good question. And we will never know the answer, Alex. This is the question a philosopher named Derek Parfit asked. Is the teleportation machine really a form of transport, or does it get rid of the original you and replicate a copy in a different place? The chances are it does the latter. Let's imagine that you, Alex, interfere with your future self and treat it badly. This is considered immoral. Parfit says that any kind of harm that one person causes another is morally wrong. Even if you're harming yourself, your future self is a different person. So, basically, a poor diet or skipping the gym is morally wrong too, just like any other risky behavior or endangerment. In his opinion, society must protect individuals. That's why, in Parfit's philosophy, teleportation is wrong. So, in a world where such a machine exists, the philosopher's supporters will be the ones who will protest against the use of teleportation machines. Just like environmentalists today, who stand against airplanes because they harm the environment, the new activists will stand against this human teleporting machine. Can you sense the dilemma now? Are you ready to possibly get rid of yourself and teleport your perfect copy to New York just because an 8-hour flight is a small inconvenience? Okay, I understand that maybe your body can be broken into millions of particles and then get swiftly transported to a different place and get put together again. But it's hard to imagine how the trick could possibly work with your consciousness. It's non-material, you can't split it into anything. Then how does it travel? On the other hand, you, Alex, fall asleep every night and then wake up the next morning. We can't know for sure that yesterday's version of us doesn't just vanish, and today's version isn't a new one, and there won't be another you tomorrow. Maybe we regenerate every night. If that's so, then teleportation won't be any worse than falling asleep every night, like we've always been doing ever since we appeared on Earth. Or maybe there's a new replica of us every time we enter a different room. There's a possibility we're regenerating all the time without even realizing it. And here's one last paradox for you. 2,000 years ago, Theseus founded Athens. The guy had a ship, and over the years, the ship started to decay. So people started renovating it plank by plank until there was not a single piece left on the ship that had been there originally. So Theseus's ship is practically made of new material. Then, is it still Theseus's ship, or is it something else now? If it's not the original ship anymore, then at what point does it stop being the ship of Theseus and become something else? Some might think it happens when the first plank is replaced. Others will argue that it transitions before the last plank is replaced. And someone else will say it happens somewhere in between. Now, the same thing actually happens to us humans. We regenerate all the time. Some organs live seconds and minutes, others last hours. But the regeneration process happens all the time, and we're not the exact same person throughout our lives. Then, how is it different from teleportation? Sure, when you, Alex, step into that machine, you're about to vanish. But it's not going to be any different from how you vanished since you started watching this video. While you were watching, the previous version of you disappeared. And if you're ever teletransported to New York, it's not going to be any different. Anyway, possibly destroying your original self isn't the only problem. Actually, Derek Parfit was describing his ideas on teleportation on the example of moving from Earth to Mars, and he went even further. Let's say humans got concerned and managed to upgrade the teleportation machine. Now, it doesn't destroy the original version of you, but rather just creates your replica in the destination place, and that replica will remember the teletransportation on Earth in the first place. Now, there are practically two of you in the universe. Let's say you two get to meet. Then you, Alex, can talk to your perfect replica. But since you can talk to them, then that means that they are not you. If you pinch yourself, they will feel nothing. If you get sick, they won't feel anything and will stay healthy. So they are you, but they are also a different person. So they aren't really you. Okay, I'm going to have to go and untwist my brain from all that. Bye for now.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1. The Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone. We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night. And during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars? It's just an empty, endless desert. Venus? Only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of super liquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light-years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars's satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.
Bang. That's how it all started, around 13.8 billion years ago, and was figured out over the past 100 years. Everything we see in space today, planets, asteroids, comets, stars, it wasn't there at the beginning. In the 1920s, astronomers came up with the idea of how a long time ago, the universe was just a single point, an extremely hot, like trillions of degrees hot, compact, dense point that stretched and expanded unimaginably fast. Matter that started flying in all directions at the speed of light at one particular moment. The Big Bang was complete chaos, with teeny-tiny particles that were mixed with energy and light. Yes, a total mess, but still, in the first minute after the Big Bang, the base for everything that would later appear was almost finished. It was hot only during this huge blast. As soon as the expansion started, the universe began to cool down, similar to when gas cools when you spray it from an aerosol can. During that process, part of the energy kinda froze out, just like the water freezes into ice. Here, pure energy got frozen and solidified into matter. 1 minute after the bang, the cooling thing was still going on, extremely fast and literally everywhere at once, since the universe really doesn't have edges. It wasn't just a compact dot anymore. The base for further expansion and all that's coming was being formed. Remember those tiny particles from that first boom stage of the universe? They started grouping together, which formed atoms of helium and hydrogen. It took about 3 minutes for most of the helium and all of the hydrogen in space to be made. These two are the most common elements and the basic materials that later formed the first galaxies and stars. Just because the base wasn't finished doesn't mean the creation of the universe stopped after those first couple of minutes. True, after that, no new elements were created for millions of years, which is why the initial version of the universe was entirely helium, hydrogen, and energy. But eventually, atoms began to slowly group together, which, after lots and lots of time, caused the creation of galaxies and stars. Clouds of helium and hydrogen grouped and turned into stars that had gravitational forces. Our Sun is also made of 3/4 hydrogen, while the rest is helium. 1/4? Yeah. At later stages, some other, heavier elements started to show up too, such as carbon, iron, oxygen, and so on. It wasn't all about chemical processes where new elements, stars, or planets kept coming. The whole universe has been expanding ever since the Big Bang. Researchers realized other galaxies are kind of moving away from ours. Guys, you need to stop doing that. How will we discover alien life out there if you keep running away all the time? And not just that. The farthest galaxies are actually moving quicker than the ones closer to our galaxy, the Milky Way. The universe is fabulous, unknown, mysterious, scary, and completely silent. Imagine yourself floating in your spacesuit somewhere above Earth. All you can actually hear is the sound of your own breathing, nothing from out there. Since there's no atmosphere, sound doesn't have a way to travel or be heard. Speaking of spacesuit, that thing costs around $12 million. I guess that means we'll have to wait up a little bit more to try that whole chilling in space thing. Mercury is the closest planet to the Sun, so you might think it's the hottest one too. And yet, Venus actually takes the title of the hottest planet in our solar system, with the surface baked by a temperature of 840 degrees Fahrenheit. Fair enough. Mercury doesn't have an atmosphere, which is in charge of regulating temperature, so it loses the race for the title of the hottie of the solar system. Venus also has pretty long days. Just one takes around 243 Earth days. Now that comes in handy for those people with pretty long to-do lists, who like to take it easy and slow. However, Venus orbits the Sun in 225 Earth days, which means 1 year there lasts 18 days less than a Venus day. You can have 2 birthdays in 1 day then? Well, 2 birthdays in a day could be one of the good sides, but the downside is that on Venus, it rains sulfuric acid and snows metal. Not so fun anymore, huh? The Earth is cool itself. Being 4.5 billion years old and the only known planet that supports life, it also has more trees than there are stars in the Milky Way. 3 trillion, while there are only 100 to 400 billion stars. We may have counted trees, but still, so little do we know about our ocean. Only 5% of it is explored, so we know less about it than about Mars or the Moon, whose surfaces have been fully mapped. It's funny how outer space is just 62 miles away from us, counting from above sea level on our planet. Seems so close, I sometimes go that distance just to have my breakfast. And yet, only 5% of the universe is visible from Earth. 68% of it is dark energy, while 27% is dark matter, which we can't see with a telescope. So close, yet so far. We will always see the same side of the Moon no matter where we are on Earth. The Moon rotates on its axis at the same speed it orbits the Earth. This is called synchronous rotation. Sunsets on Mars are blue. That happens because the fine dust on the red planet has the size perfect for blue light to efficiently penetrate the atmosphere of Mars. So the blue light scatters, after which it stays closer to the direction the Sun goes, unlike the light of other colors. The universe is full of wonders, and one of them is a planet made of diamonds. Yay! It's twice bigger than the Earth, and scientists believe it's mostly covered in diamond and graphite. Now to get there, you might probably need that $12 million spacesuit, together with a really expensive ship. But if, and that's the key word here, you manage to go there and back, you may even easily pay it off. Scientists also have some predictions as to the end of everything. Oh boy, ready for this? At its early stages, the The whole universe was dense and compact, so it was really thick. But after around 400,000 years, it kept expanding, which made it more transparent. All of this encouraged releasing light we know today as the cosmic microwave background, or CMB. It's like if you turn your TV on an empty channel and switch off the cable, you'll see the static black and white dots moving on your screen. There's something like the CMB, and also an afterglow of all that energy that was released during the Big Bang. CMB is still here. Astronomers can see it through the microwave telescope. Expanding never actually stopped. The universe is still spreading every second at an unbelievable speed, causing all the objects in space to move away from each other all the time. How repelling! We know it because the sun from other galaxies appears redder than it's supposed to be. This is called red shift, and it happens when the source of light moves further from the one who's observing it. Then there's gravity. It attracts all objects in the universe to each other, which is the reason why planets keep orbiting the sun, or why our solar system orbits the center of the Milky Way. It's why we stay on the ground, while in space we'd float since there's no gravity up there. Having all this in mind, scientists got the idea that one day the universe will simply take the opposite direction and start shrinking back, which will be known as the Big Crunch. Whether this really happens depends on the type of our universe. If it's open, it'll keep expanding and nothing will ever stop it. But over time, as it's stretching, the density will become so low, galaxies won't be able to form new stars, and the existing ones will fade away. When space loses all the light and heat, life won't be possible. The universe will just remain as a cold beyond, which will keep spreading thinly into endless darkness. And then, Big Crunch or not, bang! It all disappears. Hey, good thing we have billions of years ahead of us, huh? Well, maybe you. I won't be around then. I'm going to retire. Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star. and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, The Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the Lion, and in winter, it's Orion the Hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.